Buckle up, folks. This one is a very hard one. So if you're a new viewer, welcome to my channel. And if you're returning, welcome back. This one is one of the few hard problems from Hackerrank on Python programming, but I will make sure you understand it as easy as drinking water. Well, at least I will try. If you're a frequent visitor to my channel, you will know that I've got Hackerrank on the left-hand side. That will help me to introduce the problem to you. And I've got a Jupyter notebook on the right-hand side, which will help me teach how to tackle this problem. A lot of you have been asking, how can I get better? Honestly, just keep doing it. Keep solving Hackerrank problems, lead code problems, and many other sources of information that you can find, which will help you with the problem solving. Soon, I'll be releasing videos about generic problem solving and critical thinking. But today, my focus is to make this one as easy as a pie for you. This problem is called Maximize It, and there is only 81.9% chance that a lot of you will be able to tackle this one. Let me extend this window, and we'll see what the problem is about. I'll probably start with the input format, because then reading the task for you will make more sense. Let me show you. The input format will be, as you can see on the screen, as I have highlighted. The first number, which is number 3 in this specific example, defines how many number of lists you will receive from the user. So I will receive 3 lists from the user. So that's number 1, number 2, and number 3. So the user will give you 3 lists. And then the second number defines the modulo number. Keep that at the back burner. Let me come back to it later. For now, I'm not talking about that one. But each list will start with a number at the front of the list. For example, in the first line, it starts with number 2. That number 2 defines how many numbers will exist inside the list, which you can see, 5 and 4. So 2 numbers there. The next list says 3, which tells me I've got 7, 8, and 9. And then the next one is number 5, because there are 5 numbers in the third list. So this is the type of input you will be receiving from the user. The number of lists, the modulo number that I will just right now talk about, and then you will get the length and the actual list in the following lines. Before I move forward too much away from this modulo number, let me just remind you that in Python and in mathematics in general, there is a concept that we call the modulo. For example, if you find the modulo between 100 and 9, you will receive number 1. This modulo operator, which is essentially the percent sign, it shows you what is the remainder of the division of 100 by 9. Well, there are 11 times 9 in 100, because 11 times 9 is 99, and the remainder is 1. Or maybe if I show you the modulo between 7 and 5, as you correctly guessed, will be 2, because 7 equals 5 plus 2. So that's the modulo operator I was suggesting here. I will be using this number as the second part of this modulo operation. So just keep that in mind for now. But let me tell you what the task is actually. The task is you are given a function. So the function we have been given is x squared. So let me clean up my Jupyter notebook. F of x equals x squared. So that's the function we are dealing with. I'm not going to run that cell because that's not 100% Python code. If I run that, I will get an error. Let me just keep it there. You're also given k lists. So I talked about k lists. In the example, there are 3 lists. The ith list consists of n of I elements. For example, the first list consists of 2 elements. So this one defines how many elements are in the list. So we did talk about that as well. You have to pick one element from each list. So in this list, which is 5 and 4, so that the value from the equation below is maximized. So I will have to tell you what the task is from here in my own words. So imagine you have these 3 lists, which I am happy to write them down for you and then run you through how it works. So I've got 5 and 4. That's the first list. I've got 7, 8, and 9. That's the second list. And I've got 5, 7, 8, 9, and 10. So these are the 3 lists that I'm dealing with. Again, I'm not going to really run it because this is not very correct Python code. I'm only using that as a placeholder. The challenge we have been given is that from each of these 3 lists, you can take one number right? For example, I will take 5 from here, just randomly. I don't have any reason for that. And I will use this function, which raises it to the power of 2, and add to another number from here. Maybe I'll take 8, again, no reason, and raise it to the power of 2. And another random number from here, I'll take 7, and raise it to the power of 2. So this will be this first part of this equation. But if you look at here, I will have to perform the modulo operator. So once this is done, let me calculate that for you, which is 138. I need to perform for all of this modulo by 1,000. You may ask, hey Amir, where did you get number 1,000 from? Well, that was the input from the user, if you remember. The user has asked me to find a modulo by 1,000. So if I run that, the remainder will still be 138 because this equals 138 and its remainder for the division by 1,000 is still 138. So going back to how I was selecting these numbers from these lists, I said that I will be choosing randomly, but I don't think what the task is asking me. Let me go back up to the task. So I know I will be doing these 2 lines. Xi denotes the element picked from the ith list. So I picked 5 from the first list, 8 from the second list, 7 from the third list randomly. I will come back to that. Find the maximized value obtained. Modulo denotes the modulo operator, which we know that. Note that you need to take exactly 1 element from each list. So I need to do some sort of calculation that says, if you take this number, and for example, this number, and perform this operation, the outcome will be the highest value you can get. So in a sense, I need to find the maximum value I can get out of here. So let me just do something very quickly. If I take 5 from here and take 9 from there, I'm trying to take the biggest from each list, and 10 from here, I will get 206, which looks like that's the correct answer. But is taking the maximum of each list the exact answer that we are after? I don't think so, because of this modulo operator. This might go really, really big, for example, and be 1005. And the modulo of 1005 and 1000 is 5, whereas the modulo of 999 and 1000 is 999. So I don't think finding the maximum value is the right answer, and Hackerrank already tells me that. Note that you need to take exactly 1 element from each list, not necessarily the largest element, for the reason that I just explained. You add the squares of the chosen elements and perform the modulo operation. That's what I've shown you. And the maximum value that you can obtain will be the answer to the problem. I will extend the Jupyter Lab, and hopefully I will be able to explain this in very simple terms. But think about the logic. You are only allowed to take 1 element from each list. So you need a loop for each list. Let me use 1 for loop as an example. And then you also need to loop between the lists. So 1 loop for inside the list, and then 1 for between the list. That's so far 2 for loops. I will need 2 for loops. 1 that goes through this one, and then 1 that goes through this one, and this one. This will continue going through each and every element within each list. And I will need to be performing this function right here. And when I do that, I will be adding those values to understand if I can achieve the maximum value. If I were to perform this not with the for loops, I would do something like this. I would take number 5 from here and use this function. That would be 25. And then I would take 4. I know that I'm not going to be taking 2 values from each list, but I want to keep it in my mind which one is the best option. So my options here are 25 and 16, because 5 squared and 4 squared. So those are my options from the first list. From the second list, I've got 49, 64, and 81, right? And from the bottom one, I've got 25, 49, 64, 81, and 100. So you can see the logic I am going through. So once I have done that, there are multiple operations that I have to perform. Operation number 1, take 25 from here. So take 25 plus 49, 49 plus 25. So that will be option number 1. Option number 2 will be still take 25 and take still 49, and then don't take 25 because you've already tested that one. This time take 49. Option 3, still take 25 and then still take 49. So I will take 49 from the second list. I have already used these two, so I will be taking 64. And so forth. So you can see that I will need to run such an algorithm for me to be able to perform all these many options, and then at the same time to check if the modulo of 1,000 is the maximum. Or maybe keep all of them in one set because I don't want duplicates. The set gets rid of duplicates and I want to find the maximum value. So with all that explanation, I will start doing some coding and then testing on Hackerrank to see if my solution is the right solution. So let me clean up this cell because I don't really need that, but I will start doing some coding, and as I go down, I'll explain what I'm thinking while doing this. So for me to be able to start doing the coding, I need to accept the input from the user. So I know that the user first line will be K and M, and I will be receiving them through the input function. If you haven't seen my video on the input function, the link is up the top right. The input function will give you everything in a string format. So from what I can see here, I will receive the value, the number of the list, and the modulo number in one go. So I need to split based on the space because there is a space between them, and I will use that space to split them. Then I will be using the map function to map them into integer values. So that's one thing. The other thing I will be getting will be these different lists in an iterative way. It's time for me to accept the lists from the user. So let me make an empty list to hold as a container, and whatever the user gives me, I will put in the container. So that's my empty container. Now I will write a for loop that accepts the number of lists from the user, which is K at this point of time, and iteratively, I will append whatever the user gives me into the container that I have. How does the input from the user will come? Well, it will come through an input function. I know that. But remember, they will come in one box of strings. So I will need to split them based on the spaces between them. And I also need to map them to an integer value. So if you haven't seen my video on input function, the link is up the top right. So once I have mapped them to an integer, I know that I do not need the first number because the first number only gives me the number of elements in that list. I don't need that. I don't need this, I don't need that, and I don't need that. So all I need to do now is to only from here convert all of this to a list, and let me close all of them. And from that list, all I need is starting from number 1 to the end. Let's see if this works. If not, I will just troubleshoot it. There is no problem. So run that. It says, hey, this is not really what I've forgotten that space there. Let me run that. So I will paste exactly what is on Hackerrank. So 3 space 1000. And this one is a comma. That's my bad. Let me run that again. Just got an additional bracket there. All right. 3 and 1000. Okay. The first list is 2, 5, 4. Let me just input them 2, 5, and 4. And then 3, 7, 8, and 9. And then 5, 5, 7, 8, and 9, and 10. So if I show you K, that's 3. If I show you M, that's 1000. And if I show you the lists, you will see that I've got the 3 lists really nicely tucked here. So this is brilliant. I have now accepted the user's input. Now it's my turn to perform the operation. If I go back to the analogy that I was running you through where I was taking 5 and that was 25, this one was 16. So I went through all of them one by one. So let me make a new variable and call it possible sums. This possible sums will be an empty set as we start. But before I do that, I just want to make it a 0 because I don't have anything as a sum right now. I haven't summed up anything. So that sum will be a 0 and I will store it in a set because I just want to get rid of all duplicates. So let's start with a sum of 0. Then, as I said, I will have to go through different loops to be able to check if I am doing the right thing. For me to be able to do that, I will have to go through every list as a parent for loop. Let me do that. For LSD in lists, let me first show you as a print function that what this does, each iteration takes each list as it goes down. So now I am able to iterate over lists, which is good. Now, within each list, I don't really need to print it. So let me get rid of the print function there. All I need to do is to perform the square function. So maybe for each number in that list, I need to print the number squared. Once I print the number squared, you will see that, okay, I am on almost the right track. 25 is the squared value of this one, 16 is the squared value of this one, and so forth. But what I haven't really done is to separate these two from this 3 from this 5. I want to go into a list, which is, for example, this one. Once I have done that, save the squared values in a new set. So let me do that. I will just call it new set. New set equals an empty set, right? I didn't mean to call it new set. I meant to call it new sum. And the new sum is the small container that holds per list the squared value. If I run this again, you will pretty much see the same thing. But I also want you to see something. This new sum I created so that I can hold the summation of the squares per list. So what I need to do right now at each iteration for a number in that list, so let me update my new sum every time. The new sum adds the value of the new number squared. And if I print the new sum, you will see that as it goes down, it will update with new information. Let me just get rid of this print function because you've already seen what it does and it will just be confusing to have multiple prints. So you can see that it takes this number 5 and puts it into the new sum, which is correct. Then it goes back up, comes down with number 4, squares it, and also adds it to new sum. So you can see that at each iteration per list, I am squaring it and then adding them into a bucket or a small container. And now all I need to do to be able to capture the maximum value of the modulo is to combine it with possible sums. But I just said one word, modulo. Did I really consider the modulo? I haven't really considered the modulo. Let me just put it down here because at each iteration at the end of the day, I have to care about the modulo. In order for me to be able to combine the possible sums, which is the bigger container, with this smaller container that I just called new sum, I need to write another for loop. I'm sorry, but if I don't do that, it's not going to work. I will write a new for loop that says for s in possible sums. All I want you to do is to perform the same thing, but at each iteration, add this new sum to the previous value that was captured in the possible sums. Because I want to find the maximum value. I want to say, hey, add this 16 to this 64, to this 25, and as we go down, make sure from each list, take one, add them all up, and then put it in the bigger container. I will run you through that again, but let me fix this one as we go. Then I will have to add that s to the new value. So if I print this one right now, you won't really see much of a difference. So this is not going to make any changes to the new sum, but once I come out of that loop, I can say possible sums then equals the new sum. So if I run this, you will see that possible sums at each iteration of a list gets updated by replacing with the new sum into the possible sums. And if I go scroll down, you will see that this keeps growing. And at the end of the day, I end up with a huge set that has got every possible combination of squaring and adding each element from each list so that we have that. Now, all I need to do is simply find the maximum value of this bigger set. What exactly I'm doing? Well, if I look at the possible sums, that's what this is. And if I find the max value, which is just a Python built-in function, you will see that it's 206. So I will just pause a bit here, take this code and put it in Hackerrank and see if it actually Hackerrank agrees with me that this is a really good idea. Let me clear the outputs from here, or maybe just get rid of print because I'm not going to be printing on Hackerrank. And then all I need to do is to find the maximum value. So maybe make this a bit smaller and copy the input functions into Hackerrank, paste them here, and then copy these lines, paste them all the way here, and then copy and paste this last line here. So do that, and maybe just put a print function there so that Hackerrank really sees this taking effect. Run that code and let's see if that works. If not, we'll have to troubleshoot. So the test case did run. Now I need to submit the code to run more test cases. Maybe we'll time out. Yep, some of them have timed out because the answer is wrong. So let's go back and make some amendments to our code. I'll go back here and I'll show you what amendments I'm making here. I think one of the really important things I would be doing here is rewriting this for loop. I know that it's not going to really matter for the timeout of the operation, but if we are writing professionally, we should kind of write our code in a better way. So the way I would write this would be in a list comprehension. I've got a really nice video of list comprehensions. You can go ahead and have a watch. But essentially, what we want to do, we want to take this bit from this part of the code, put it here, and also take that bit and leave it to the bottom. So that I don't also need that one. So take that and put it in Hackerrank. I'm starting all over again from Hackerrank. So I've deleted all the previous code. With this one, I don't think I really want to change anything, but let me double check. So this is going through the lists, making a new container to hold the sums. This is going through each and every number inside the list. And this one is going through the previously measured summaries. But I think here I need to add another bracket because otherwise it will not really make sense to do it this way. So maybe that was what was going on with the previous code. But let me just copy that, bring it back in here, and then also print the maximum of possible sums. Let's submit this one and see if it fixes the problem. It did run successfully in the first test case. That wasn't our problem. Let's just submit the code and see if every one of them will run. Yep, that was a success. So it was only a bracket problem that I needed to add, which I'm happy that I found out. So if you enjoyed this video, hit the like button, share it with your friends, and subscribe to my channel. I'm making a whole heap of videos that you don't really want to miss.